In this video, we'll look at the values of trigonometric functions in all four quadrants. So one nice thing about the trig functions is that we can tell exactly which quadrants they're going to be positive and negative in. So if I've got the four quadrants here, so I'll label them 1, 2, 3, and 4. Every trig function is positive in the first quadrant. And that makes sense because if you remember how the trig functions are defined, so let's just draw a circle here. Then when we first started doing this, we said that the things were defined in terms of the x and the y and the radius. And so in the first quadrant, everything is positive, the x-coordinate and the y-coordinate, and so all six trig functions will be positive over here. Now in the second quadrant, the only two trig functions that are positive are sine, and to go with that, of course, cosecant. In quadrant 3, tangent is positive, and of course also cotangent. And then in quadrant 4, cosine is positive, and then of course also secant. So in quadrants 2, 3, and 4, in each quadrant, 2 of the 6 trig functions are positive and all the rest of them are negative. Now there's a nice mnemonic for remembering this, and you may have seen this in high school. It's A, S, T, C. So A for all, S for sine, and then cosecant comes along with it, T for tangent, and therefore cotangent, and then C for cosine, and secant goes with it. And there's a couple of cute little jingles that you can put with this. So you could, for example, have a smart trig class, or all suckers take calculus. If I could spell, it would help. And then one that former students of mine shared with me is kind of nice. Alvin, Simon, Theodore, chipmunks. Okay, so any of these can just help you remember which are the two, or in the case of quadrant 1, all of them, trig functions that are positive in that given quadrant. So using this, we can tell exactly what quadrant we're in if we know information about, say, 2 of the trig functions. So for example, if we're given that sine of theta is a negative number, then all that tells us by itself is that we're either in quadrant 3 or 4. Because sine theta would be positive in quadrant 1 and also positive in quadrant 2. Now, if we add in an extra condition that cosine theta is negative, then cos theta can be negative only in quadrants 2 and 3. So, which quadrant will have both of these things true is just the overlap of them. So sine's negative in 3 and 4, cosine's negative in 2 and 3, and the only one that's common to these is quadrant 3. So if we say that sine theta is negative and that cos theta is negative, we know immediately that theta must be somewhere in quadrant 3. Now we can use this to solve sort of very simple trigonometric equations. So let's, for example, say that we know something about sine and cosine. So one of the relationships that you have between them, and this should make sense because it's basically just Pythagoras' theorem is that you can solve for sine in terms of cosine by looking at this equation here. Sine squared plus cosine squared must equal 1. And that's only works if the angles are the same, but they will be in this case. So one thing that you can do is, so let's say that we know something about cosine and we want to solve this for sine, then you can, first off, let's just move the cosine over. And then if we got something squared on the left, we'd want to square root both sides. Now there's a little bit of a problem that when you do that, namely, there's a plus or minus. So how are we supposed to choose whether or not it's plus or minus? Because strictly speaking, for any angle, sine of theta is either positive or negative, but it can't be both at the same time. So we need to know how to choose correctly which of the signs should come in front. Should it be plus or should it be minus? And the way that we do that is figure out where theta is. So for example, if using information we can determine that theta is definitely in quadrant 1, then we know that sine theta must be positive, and hence we need the plus out front. If, for example, we know that theta is in quadrant 4, then over here sine is negative, and hence we need the negative out front. So which one, the plus or the minus, you'd use depends on where theta lives. Okay, so in the next slide we'll look at a specific example of this. Okay, so let's look at a specific example here. So let's suppose that we're given that cos theta is 15 divided by 17, and that whatever the angle is, it makes tangent negative. These two pieces of information allow me to determine what quadrant theta is in. So if you think, where is cosine positive, it's in quadrants 1 and 4. Whereas tangent negative, it's in quadrants 2 and 4. And so those two pieces of information together tell me that theta is in quadrant 4. And this will be important later. Okay, so what we want to do in this problem is to figure out what sine of theta is, tangent theta, and so on. So we want to find the value of all 6 trig functions at theta. Now the thing that's neat here is we actually have no idea what the angle is. Like, I can't say it's 300 degrees or something specific. All I know is that it's in quadrant 4. Now later we'll be able to figure out what exact angle theta needs to be. But for now, we actually don't need that information. So let's figure out sine of theta. Well, we know from the previous slide that this is plus or minus 1 minus cos squared. And so for us here, it'll actually be the negative. Now why the negative? Because in quadrant number 4, sine is negative, and so that's why I know I need the negative out front here. I also happen to know what cosine theta is because that was given, and so this thing here is 1 minus 15 over 17 squared, and we just need to simplify and compute this. So if we do the arithmetic here, then 15 over 17 squared happens to be 225 over 289. And then 1 is the same as 289 over 289. So I'll subtract those with the common denominator, and I get 64 over 289. Now I already know that the square root of 289 is 17, and I already know that the square root of 64 is 8, and I need a negative here. So what this tells me is that sine of theta is equal to negative 18 over 17. Similarly, we can do this to figure out tangent and cosine. So now in this case, we already know what cosine is. It's 15 over 17. So there's actually no work to do for that one. But now we can easily get tangent, because if you remember, tangent is the same as sine over cosine. Sine we had was negative 8 over 17. And if I'm going to divide that by cosine, that's the same thing as flipping and multiplying. And then notice that 17's cancel. So I get negative 8 over 15. Okay, so once you get both sine and cosine, the rest of this is actually pretty easy to crack. Okay, so there are 3 of the trig functions, but we need the other 3, and these 3 are really easy. So for example, what is secant of theta? Well, that's just 1 divided by cosine. We know cosine's 15/17, and so 1 over that is the reciprocal. Similarly, cotangent is just the reciprocal of tangent, and that in this case is 15/8 negative. And then lastly, we know cosecant is just the reciprocal of sine, and so it's 17/8 also negative. So just to double check that everything makes sense here, there should be only 2 of these things that are positive. So there are only 2 ways that this can work out. 2 are positive and 4 are negative, or all 6 are positive. In this case, we've got tangent's negative, cotangent's negative, cosecant's negative, and sine is negative, so there's the 4 negatives, and secant and cosine are positive. And that makes sense because those are the only 2 trig functions positive in quadrant 4. So what this tells us is that we've got all the negatives and positives sorted out, and as long as we did all the correct arithmetic here, then everything is good.